Hello everyone, welcome back to another video in the series 15 days of machine learning. In this video today we'll be looking at latent Dirichlet allocations algorithm, and I, Jay Vishwanath, will be your instructor for the day and will be taking you through this one of the most famous and versatile algorithms known to us in the world of machine learning. So before we get started with LDA, let's just find out the implications of LDA and the beforehand. So for that we need to look at topic modeling. So topic modeling is basically a method for unsupervised classification of documents. It is very similar to clustering on numeric data. It basically finds some natural group of items even when we're not sure what we're looking for. Say you have a document which has X number of topics, and you don't know the topics and you don't feel like reading it all the way through. So what the topic modeling does is it classifies the documents on the basis of a number of topics, and topic modeling is a type of statistical modeling for discovering the abstract topics that occur in collection of documents. So the abstract meaning the hidden document, hidden topic which we do not know. So topic modeling helps you do so, and in this, one of the most famous algorithms to do topic modeling is the LDA algorithm. LDA stands for Latent Dirichlet Allocation algorithm. It is very similar to k-means in clustering, and it is one of the most popular topic modeling algorithms used. It is basically used in Python, and it is very easy and efficient, and it also easily helps you to grasp the core of machine learning. And yeah, so that's about it. So the basic aim of the LDA is to find a topic a document belongs to and based on the words in it. So LDA works on basically grasping all the words in a document and processing it and filtering it into a number of topics, a latent topics, which the user will decide beforehand. So here we can see a graphical or a scientific diagram of the LDA model. It is basically works on two parameters, Dirichlet parameters, alpha and beta, which we'll get to in the coming slides. So let's look at working of LDA. The basic working of LDA is in two steps. The words that belong to a document that we already know. There must be a document in which the words may be present and which we already know. So that becomes the first Dirichlet parameter. And the second, the words that belong to a topic or the probability of words belonging to a topic, which we do not know. So we do not know the words which will be belonging to a specific topic. And so the LDA helps you figure this out exactly with the help of probabilistic statistics. So let's find out how the LDA does this. So it basically goes through each document and randomly assigns each word in the document to one of the k topics, and the k is chosen beforehand by the user. And for each document D, it goes through each word W and computes the proportion of words in document D that are assigned to topic D. It also tries to capture how many words belong to a topic D for a given document D. So in a given document, it tries to figure out basically the proportion of words in the number of words which can be assigned to a specific topic. It does this with every word in the document. The second word, the thing which it does is the portion of assignment of topic T over all documents that come from this word W. So it tries to capture how many documents there are in topic T because of the word W. So this is the basic working of LDA. So here we can see basically the document topic distribution and topic word distribution. It takes both of these factors into mind and creates a probability scale by assigning each word to the given number of topics k, and it comes out with an outcome. So for this, LDA algorithm using GenSim and NLTK. So one of the most famous open source libraries for unsupervised topic modeling is GenSim. GenSim is basically present in Python, which is a module, and NLTK is also a Python module which helps you to perform natural language processing. So it basically helps in the cleaning of the document. Say you don't want any hyphens, exclamation points, synonyms, or adwords. It helps you to clean them for an accurate result of topic distribution. So now let's get right into the code. For this you will need to install GenSim with pip, which is pip install GenSim, and for the example which will be followed, we will require to install Wikipedia so that we can get a few documents. And the third which we'll need is NLTK, as I mentioned, for data document cleaning purpose. So once you have downloaded all three of these, now we can start coding. So let's say we want the LDA algorithm to divide the topic into 4 parts, that is Mona Lisa, Taj Mahal, COVID-19 pandemic, and data sciences. But the LDA model does not know that these are the topics. Why? Because now we will be creating a corpus of these documents. So corpus basically in machine learning means the combination of all the documents. So what we'll be doing right now is taking all of these documents and combining them into one single document for the LDA model to divide it according to the topic. We are taking this for us to see and to conclude. In real life we will not be needing this, and there will be a whole document in which we have to divide the topics. This is just for our convenience. So we'll be taking all of these and COVID. As we can see, all these are totally different topics, so it should be quite impossible for the algorithm to do so, but it will. So once we got all of these, now we have an error. So this is capital. So it has been processed. Now we can see that if we type corpus, we can see all the words, all the whole document which has been merged together. So from this we can see that there are a lot of brackets and hyphens and backslashes. So we need to clean this data basically to help get an accurate topic distribution. So if we say type of corpus, what we'll be getting is we should be getting the type of the corpus, which is a list. It is basically a list because we have taken it in square brackets. So once we have done this, we will be cleaning our corpus. So for cleaning our corpus, we'll be using NLTK, and from NLTK we'll be importing word lemmatization. Lemmatization is basically combining of similar words into one word for our convenience. So here we can see a basic data cleaning, document cleaning method. So what we have done is basically downloaded stop words in English for English stop words, and we have defined a function reprocess text, and here we will be using all these commands, which is basically syntax of NLTK, to remove special characters, remove all single characters, remove multiple spaces to a single space, remove a single character from start, and convert all to lowercase. This is all for the convenience of us as well as the LDA algorithm, but mostly for the LDA algorithm. And after we have done this, we'll be lemmatizing, and we'll be taking a token. Tokens are basically the individual words in the document after the data document cleaning, and we will be lemmatizing the similar words into one word. Once we have done that, we will be processing the data, into a list. Here we can see we have used square brackets, so we'll be processing it into a list. So if we run this, it should run. Here we say downloading package stopwords completed, and is already up to date. That means it has completed. Now we can proceed with building our LDA model. So as mentioned before, the gensim in Python, gensim is used for LDA modeling. So it is an open source library for unsupervised topic modeling, and it uses modern statistical machine learning. So we will be training our corpus, the corpus. So once we have imported gensim, we'll be converting our process data into a dictionary. We are converting it into a dictionary because we will be getting unique key and value pairs for the LDA model to quickly take and assign it into the specific number of specific topics which we have allotted. Once we have converted it into a dictionary, we'll be using we'll be converting it into a list, but this list will be different from the previous list. Why, you may ask? Because we'll be converting the document into a bag of words. So bag of words basically means it converts it into a list of tuples of token ID and token count. So this will help the LDA model to train more efficiently as well. And we say allow update equal to true, meaning that it will update itself by adding new tokens from document and updating internal corpus statistics from the training it gets every time it passes over the corpus. So this input underscore corpus will be returning a basic of int comma int type of representation. So if we say we want to view the dictionary input underscore dictionary, so we can print the dictionary. If we print the dictionary, we can see the unique tokens. There are, after cleaning of the data, all the data of the 4 documents, we can see that there are 3137 unique tokens, and it is obviously arranged in alphabetical order as abeyance, absolutely, academic, access, etc. So let's say we want to access 100th word. So here we can see blending. So it has been arranged in dictionary. Similarly, if we want to print the input the tuple of unique token ID and token count, token basically refers to the unique words. So what we do is unique input underscore corpus. Once we did that, we can see all basically each and every token ID, token count tuple. So if we scroll all the way down, there should be 3137. There are 3136 because it is starting from 0. Hence each token or word has been allocated a specific ID with the count as well. So once we have gotten all of these, now we can move on to actually training our LDA model. These are all the parameters required. We have completely cleaned our data, assigned each token the token ID, and we have counted each data, counted each token with the number of times it's occurring. The data has been cleaned. Now the easy step is training the LDA model. So training the LDA model in Python, especially gensim, is very easy with a few lines of code. So let's say we want to let's take a variable LDA model. LDA model is equal to, now for training we'll be using gensim.models and next we'll be using LDA model dot again LDA model. This is just the basic syntax which is of gensim, which gensim provides. Now in this we will be including first of all the corpus, that is all the tuple, the token of words included. So here input underscore corpus, we'll be using it. And now as I've mentioned, we have to assign k number of topics, which has to be pre-decided by the user. Now since for our convenience, since we have taken 4 number of topics, we'll take the topics as 4 as well, for us to better understand and visualize the result. And next we'll be using another parameter, which is id to word. What id to word basically is it is a dictionary of tuple int and string. It basically maps, it is a mapping from word id to words. Each has been allocated a unique word id from the corpus, and this each unique word id will be connected to the word itself, and that's exactly what the id to word will be doing. So basically the id to word here should be input underscore the dict, because it has, as we can remember, it has unique key and value pair. And once we have done that, we will take passes, the final one, which is let's take passes as 20. Passes basically refers to the number of passes the corpus during training. So it basically refers how many times the corpus will go through the whole document and train it again and again for an accurate result. And it is noted here that if we use a more number of passes, if the accurate will be the result. But if we have a smaller document, it is usually and mostly recommended that we use a smaller number of passes, because it will only complicate the LDA model. So once we have done this, now we can go ahead and print our LDA model. I'm doing it here only, so that is print underscore, we'll be using print underscore topics. From the topics we have chosen num underscore topics, and for the distribution of words in each topic, we'll be choosing, let's say we'll need 8 words for us to understand. So once we have chosen the 8 topics, now we will run the LDA model. Obviously it's a small model, hence it will only take very less time. So here we can see now, let's take a second to forget the topics which we have taken above. Okay, now here it's worth noting that there have been assigned 4 topics starting from 0, 1, 2 and 3. These are the 4 topics. Obviously the LDA model will not know the topic names. It has only assigned it on a probabilistic scale. So it is our job as a user to find out, read the words and understand the words, and come to a conclusion on what the topic can be. So now let's just take a second to forget the topics above and let's read each and every topic. So in the 0 topic, in the first topic basically, it says country, reported, pandemic, people, outbreak, number, health, billion. So me as a user will read it and I will try to understand, okay, there is a pandemic, there is an outbreak, there is people, and there is country and health. So I will try, I will use common sense to find out that it is obviously talking about some sort of pandemic, or basic, in this case COVID. And now let's go to the second topic. Again, we don't know the name because the LDA model doesn't know the name. Now we read the words. It says marble, garden, building, Mughal, complex, Mumtaz, design and element. So reading through this, I can see it says garden, building, Mughal. So I'm thinking it should be something related to the Taj Mahal, which is the topic we have chosen. And in the third topic as well, it says science, statistics, technique, information, learning, knowledge, analysis, machine. So it's pretty obvious that the third topic is talking about data sciences. And the last but not least, it says painting, Leonardo, Louvre, portrait, century, French, museum. So I read all these words, I try to think what can it be talking about, and it's obviously talking about the most famous painting, the Mona Lisa. Now we can see that we have combined the whole pages, the Wikipedia pages, into one document. We've cleaned the document and we've run the LDA model on the document, on the corpus. that is the cleaned document. And we can see that the LDA model was pretty accurately able to differentiate the topics and give us a clear-cut image, clear-cut understanding of what the 4 topics can be in the corpus of the documents, corpus of documents. So also here it says 0.014, 0.012, 0.011. It is basically talking about the percentage of occurrence in the document, in the whole document. So obviously we know that it's a huge document, so only 1.4% is talking about the country and 1.2% is only talking about reported, etc. But still it was able to quite accurately divide it. So this is a brief introduction to LDA models. Obviously you can play around a lot with it and it gets very complex as the document size increases. This was just a brief introduction to help you basically understand and see the working of the LDA model. And here we have only taken around 4 to 5 parameters, but you can also take a lot of parameters such as chunk size, which is number of documents to be used in each training chunk, that is each number of passes we give. And also we can also take update every and alpha, etc., which we can find it in the documentation of GenSim. So I hope you found this video interesting and useful. And LDA is very important for and convenient for us. So it is very important in machine learning that we learn the LDA algorithm, the latent Dirichlet allocation algorithm. Hope you enjoyed. Thank you so much.